All right, we're going to look at concept 8. Today we are going to look at how we can accurately write and graph an equation from a real-world problem using variables to represent two quantities. First, let's do a quick review. Remember that a dependent variable, that's going to be your variable that's going to depend on something else to make this one happen. An example might be time and distance. Distance is going to be your dependent variable because it's going to depend on the time for the distance to happen. Then let's look at the independent variable. Let's remember that the independent variable stands alone and happens no matter what, meaning using the example of time and distance, time happens no matter what. Nothing controls time. Therefore, that's going to be an independent variable. All right, let's look at our first example. If you're looking in your student success packet, you will see this. It says, Celia writes the equation d equals 8t to represent the distance in miles, d, that bikers could travel in t hours at a speed of 8 miles per hour. What we're going to try to do is first complete the table. All right, since this equation was given to us, we can use this equation to help us solve the missing blanks that are in our table. We know that time is our variable t, and we know the distance is our variable d. We can use that information again to fill in our empty spaces. So let's go ahead and fill in the missing blanks in our table. All right, looking at our first blank, I see that time stands for 3 hours. Therefore, I can say d equals 8, and I can substitute my 3 in for time. Then you just solve. Well, 8 times 3 is 24. Therefore, my d equals 24. Let's look at the next one. Using the equation d equals 8t, again, I can now look at time, which stands for 4 hours, and I can plug that into our equation. So I have 8 times 4 hours, which is 32. So my d equals 32. Now let's move on to our next blank. We know that time is 5 hours, so 8, fill in and substitute for t, which is 5. Well, 8 times 5 is 40. So we know our distance is going to be 40 miles. Okay, we only have 2 left. Now we know that t equals 10. So again, we substitute our 10 hours in for t, and we very clearly see that d is going to be 80 miles. So then we will put 80 into our table. So I'll assume you guys have caught on. So we have one more left. Now we have to see how many miles we will have traveled after 15 hours. Just like before, we're just going to substitute that 15 in for our t, which is time. And then we will see that we went 120 miles. So we'll write 120. All right, so now we've completed our table, and now we can go to part 2, which is graphing our table. All right, now we need to graph our equation d equals 8 times t. So we need to go back to concept 3 when we learned how to graph a table, which we know that we need to use the splat model. So the first thing that I'm going to have to do is I'm going to have to create a scale. All right, guys, I know there's a lot going on here on my graph, so let me explain this to you. All right, so when I splat, I gave it a scale. So on my x-axis, which is your horizontal axis at the bottom, I was skipping by 1. So as you can see, I went 1 all the way out to 15. And then I labeled my y-axis, which is your vertical axis. Now, I couldn't use my finger to write the scale on here, so off to the side I said I was skipping by 8. So my first line is going to be 8, my next line was 16, and I went all the way up to 120, since as you can see in my table, the smallest number was 8 and the biggest number was 120. Then I labeled my x-axis, which was time, for hours, and I labeled my y-axis distance, which is miles, and then I also gave my graph a title, the time of bikers travel. And the last thing I need to do here is I just need to plot our points. All right, the first point we need to plot is time and distance. Since time is our x-axis and distance is our y-axis, I'm going to plot 1, 8. So I'm going to go to 1, and then I'm going to go to 8 on my y-axis, and there's our first point. All right, so now I need to go 2, 16, and 3, 24, 4, 32, 5, 40, and 6, 80. I meant to say 10, 80, and then lastly we need to go time, which is 15, and then distance, which is 120. I now need to connect my lines, and now you're done completing your graph. As you can see, we have a nice linear line here because both our x and our y had a pattern, so therefore that's going to create our nice linear line. Now let's move on and let's solve for a different scenario. All right, now we have two different questions here. The first one is asking, how far would the bikers travel in 6 hours? About how far would they travel in 8.5 hours? If you look in your table, both 6 hours and 8.5 hours are missing. Therefore, we need to come up with the distance. Since we know the equation, which is the d equals 8t, d standing for distance and t standing for time, we should be able to use this equation and use substitution to solve for distance. Let's start with the first one. Let's start and see how far the bikers can travel in 6 hours. Well, hours would stand for time, which is going to be t. So just like we did earlier in the video, you're just going to say 8 times 6, and 8 times 6 is 48. Therefore, d equals 48 miles. The bikers can travel 48 miles after 6 hours. Now let's look at the next one. About how far can they travel in 8.5 hours? Well, we know that 8.5 hours, that's our time. Therefore, we plug in the 8.5 in for time. Now we solve. And your answer is going to be 68. Therefore, the bikers can travel 68 miles in 8.5 hours. Now it's time to practice what we've learned so far in Concept 8. So your first scenario is, at Smithville Middle School, there are 28 students per teacher. All right, the first thing you're going to do is you need to use variables to write an equation relating the number of students and the number of teachers. Please pause the video now and hit play when you're done. All right, did you get S equals T times 28? Good, so this is how you would solve this. First, identify your variables in the statement. Our first variable is number of students. We'll use S to represent that, and then number of teachers, and we'll use T to represent that. Now that you've identified both of your variables, go back and reread the statement, which is there are 28 students per teacher. So if there's going to be 28 students per teacher, therefore every teacher I would multiply by 28 students. Now looking at our variables, we have to decide which one is the dependent variable and which one is the independent variable. In this scenario, the number of students would be our dependent variable and the number of teachers would be our independent variable. Because no matter what, we are going to have teachers. But depending on how many students come into our building, we would have to hire more teachers. So the more students we get, the more teachers we must have. When setting up an equation, the dependent variable is always stated first, or you could think of it as stated before the equal sign. Then the independent variable would follow. So that is how we came up with S equals T times 28. Now let's look at the next practice problem. If 1,288 students go to Smithville, how many teachers are at the school? Use your equation from number 1 to solve. All right, did you get the answer to be 46? If so, great. Go ahead and just exit out of the video and go on to your practice problems. If you did not, please watch how we got that answer. All right, we know that we have 1,288 students. Students would stand for our S variable. So therefore, I'm going to insert 1,288 in for S, and now I need to solve for T because I'm still trying to find out how many teachers. All right, if you look at this example, we're trying to figure out what T is. Well, we don't know what T is. Whatever that number is going to be, we need to multiply by 28. So there's two ways you can solve this. You can either ask yourself, what can I multiply by 28 in order to equal the 1,288 and try to come up with a number? Or, mathematically, you can just do the opposite of multiplication, which is division. We can take our 1,288 and divide by 28. And if you did that, you would come up with 46. Remember, as we know, multiplication and division, they go hand in hand. That's how we solved this problem. All right, thanks for watching.